Okay. Present my screen. So you were doing this one, right? Yeah. Mm-hmm. Okay. Okay. Two boats are racing each other over a distance of 800 meter. Boat A starts from rest and accelerate at a constant rate of 4 meter per second square. Boat B has an initial velocity of 12 meter per second and accelerate uniformly until it crosses the finishing line at 52 meter uh, 52 meter per second. Okay, calculate which boat wins the race. So we need to say that whichever reach first that has a less time, right? So we need to calculate the time. So let's see what it is given and what how we can do that. For each boat, we have to calculate the time. So that's what. Okay. Boat A. So for both boat A and boat B, D is 800 meter, right? And the difference between is they have like initial velocity and is we have for boat A we have acceleration and boat D, we have for boat B, we have final velocity, right? Okay. So now the thing is that in the both of these, there is one more thing that got changed, is the uniformity of the acceleration and accelerate uniformly. That means it doesn't accelerate like the acceleration is constant. It's remains the same, right? So in that case only, remember, in that case only, the distance traveled is the average of the final and the initial velocity. So that's where they have taken this values, and you can see that which boat wins from here. Okay, now as I said here, let's go with the topic that what we I have suggested. Let's go through with it previously that if I mention it or not. This is the algebra. Okay, this is the thing that we have done. Really? My God. Oh gosh. Sorry, kiddo. Oh my God. That's you should have replied to that before. Yes. Okay. I thought I have done already. Okay. Sorry for that. And here is quadratic equations. Okay. There are not much, but there are still some few, I think. Those are the questions. Oops, where are the questions? What I'm doing, man? Uh, yeah, I think it's not showing in the Google Doc. That's the problem. If you download it, you will definitely find that equations. Okay. Yeah. Okay. Now let's go to this. So, as I told you that if acceleration is like uniform, let's go. This is the projectile motion that we did, not in detail, but somehow. Okay. Softball player accelerate. Hmm. Okay, no worries. So we haven't done that kind of question before. No, it's not a collision. It's just that. Okay, let me bring some notes and then we will do this. Okay, this is take a new note. Okay, now what the question says is let's draw that question and then we will start today's date. Just a second, please. Okay, now let's do something over here. Or there is one more thing that I have to add. So one question is when the acceleration is zero, okay? Acceleration is zero means constant velocity, okay? And it's true for other way around as well. So constant velocity means acceleration zero. Second point is when acceleration is uniform, is uniform. So for this one, we can say distance equals velocity times t times time. Okay. Now we can say distance equals speed time times. Okay. Acceleration is uniform. That means distance travel is. So we can take speed velocity will be v plus u by 2. Okay, v is the final velocity and u is the initial velocity. Okay, okay, so using this concept, what the question said is, now just we can make sure that we understand that. So the question said, uh, skypad page 15, question 5, right, part A. It says for boat A, oops, for boat A, what is given? Okay, initial velocity v is equals to, initial velocity is 0 and acceleration is 4 meter per second square. Okay, meter per second square. What we are going to find the t. Okay, and also it is said that the race track is 800 meter, right? Okay, for boat B, boat B, we have initial velocity 12 meter per second. We have, yeah, yes, it's not acceleration. It says that uniform acceleration, accelerate, that will be the final velocity, right? Exactly, right. So now, and we have again S equals 800. Forget about this for 1 second, right? Let's do it whatever we know. And we also want to know the T. Okay. So we know that without the acceleration, we can't, at this moment, we are not able to calculate our. So let's find the acceleration first, or whatever we have, we can do it. So for first, we can use, so either we can use first this one, v square uh, equals u square plus 2as, right? So that means if I change the subject to a, because we need the acceleration, let's see if it is working or not. Okay, so we're going to, so first we are get reading of v square. I assume that you can understand this step, 2s, right? So v square is 52 square minus 12 square over 2 800. Remember we done the a square minus b square thing, right? So I'm using that tool, 52 minus 12. So that will be a square minus b square will be a minus b times a plus b, right? Over 2 times 8 times 100, right? So in this case, a will be 52 minus 12, that will be 30, right? And 52 plus, am I correct? To 40. I hope so. Let's do that. Yeah, yeah. We will try that, but because that's already done, so I'm just want to say that if this is working or not. Okay. Yeah. Times 52 plus 12 will be 64 over 2 times 8 over 100. Okay. So that will be 2 times 20, 8 times 8. That will gives us 160 over 100. That will gives us 1.6 meter per second square. Right? Now we have A equals 1.6 meter per second square. So we can say that V equals U plus 80, which means T equals V minus U over A, right? Sorry, which equals V minus U. So 52 minus 12 over 1.6, which equals to 40 over 1.6, which equals to, so what it is? 25? 25 seconds. So this matches what we have get the previous way. Okay. And so if you are not able to understand, so even though we missed that part, that s equals in a uniform, so let's do that too. But before that, let's calculate here what the t is. So we know u a s t will gives the formula of s equals ut plus half at square, and then s equals so uh, okay, s is 800 minus u, oh sorry, is equals to u plus half a t square, which eventually gives us, this is 2. So now t square will be, this will cancel out by this, 800 over 2, which gives us 400, and therefore therefore t equals root of 40, 400, sorry, and t will be 20 seconds, right? So this is how we can get it. Now the second question, or the second thing that you said, that the let's do it what is explained in the solution, right? Here, yes, 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 yes. So this 4 will be cancelled out by 2, right? Yeah, yeah, yeah. Right. Yes, we can't do that. right? So because, so what is this means? It simply means 4t squared divided by 2. So that's why we can cancel up. No, we in this case only because there is 4t. A's value is 4. Okay, okay, okay. There has been confusion. Let's clear that one. In our equation for boat A, as I said that S equals UT plus half AT square, right? U equals 0, A equals 4 meter per second square, S equals 800. We are looking for P, right? So now I'm putting 800 here equals to 0 times T here plus half A. Now I have to place the value A here, right? And then I have to multiply it by 2, right? So this will lead us as simple as this. 800 equals half times 4t square, right? So, so because it's multiplied by 0, I 0, so it becomes 0. Okay. Okay. Now, because in this case only, so there are now many ways to do that. Okay. But the simplest ways is because here 2 is dividing 4 already as a coefficient of t square, we can cancel it out as 2. So it's simply like 4 is divided by 2. So that answer gave us 2. So if I just do now like this, 2t square is equals to 800, which eventually leads us to 2 square over 800 over 2, right? Now, sorry, this, no, 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 no. Just look at what I have done here. Okay, I'm doing it again here. Okay, let's see. So this 8 square 800 is will remain same is equals to, so this 2, because now we have cancelled 2 by 4, right? So now it is 2t square. So this one, multiply by any number by 1, it's same. Yeah. So if there is 1 in anything, it's only makes sense when it is minus 1. Okay, because again, then if it is minus 1, then it will change the uh, sign, right, of that particular number. So now we have only 1. So 1 will be remain same as the, it doesn't make any difference in the calculation because any number times 1 will be the same, right? Okay. So now I'm just flipping it up now for the ease. 2t square equals 800. Now this 2 is in the product. If we change the side, it will become the denominator, right? So t square is equals to 800 over 2, which will equals to 400, right? And then so now we have t square equals 400, taking both sides the square root, something like this, right? So this will become t equal square root of 400 is 20. So that's the answer. Okay. So the who win the race? Boat A win the race because it takes the less time than boat B. Okay. Ah, no, 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 no. Again, that's why I'm saying that it is very it good that you remember the difference between the units of a velocity and acceleration. Right? That's very positive. I really like that. It's just that you skipped while solving that. So I believe that. So now again, see, they have also asked us calculate the acceleration of boat B. Right? So you have done that. Oh, great. So we don't need this, even though we can use this formula, but we are good to go without that. I have already mentioned it's good. So you are doing good now, I believe. Nice, nice, very nice. So you are doing so again. Do some practice with the what I'm saying, quadratic equations that I have given you. Do and the all the algebra or the mathematics evolve around that. Once we are taking side, flipping the RHS to the left hand side, right? Subtracting some, if I changing from LHS to RHS, if it is positive, it will become negative on the other side, right? If it is negative, it will become positive to the other side. If it is in the coefficient or the product of an variable, right? So it will become a denominator of that, and vice versa will true. Okay, cool. Uh, yeah. Hmm. Uh, this one. Yeah. Or initial velocity. Yeah, because the final velocity is already there. Yeah. No, no, it's not. So again, if you know simple thing that let's do one more time. Okay, you have to remember this now. V square equals u square plus 2as. Okay. Now we have like three subjects that we can sort it out. One is U, one is A, and one is S. Okay. For A and S, it can be anything, but it will be the same. All the steps for A and S will be same. Okay. All right. And for you, it will be quite easy. Okay, because we have like one whole expression which is in positive, right? What we need to do is, so first thing first, we need to put on the left hand side whatever the subject is. Okay, so I'm doing is because the subject in is our currently it is on right hand side, I am putting it in the left hand side. 2as equals v square. Cool. Now u square plus 2a. So now this is a whole expression. It is in positive. So what I will do, if I take this around here, it will become in the negative. So I can say u square equals v square minus 2as. Got it? Okay. Now the next thing will be taking square root of the both side, right? So if I take square root of a u square, it will gives us u is equals to root square of whatever we calculated u square minus 2as. That's okay. So this will solve for the U. The next is for A or either S. You tell me what you want. Okay. Now, again, the first step will be yes, yes, subject. So now the subject is A. Whatever the expression in the whole equation is, we have to put again in the left hand side. Plus 2as equals v square, right? So now we are not doing anything from here, we are doing something to here. What we are uh, yes, so let's do that. U square minus u square plus 2as equals v square minus u square, right? This will become 0. This will become 2as equals v square minus u square. Now we have to find a. So what are the other two coefficient? S and 2. So let's rewrite like this. A to S, right? Is equals to v square minus u square. So what divide with that? Correct. You know, divide by 2s this side, divide by 2s this side. So this will gives us a equals to v square minus u square over 2s. Okay. In the same way, if there is s, so it will be s equals v square minus u square over 2a. All right. So this is how you are going to rearrange all these equations. Got it? Cool. All righty. So what we have now? Sorry. Yeah. So it will happen for each and every. So if there is an equation, if there are variables in it, if the question is asked to solve the equation or to get the answer from or to get the value of a variable, there always be a rearrangement. It doesn't matter. So if we say f equals minus kmx, this is the Hooke's law, right? Oops. What happened? Did I delete something? No, no, no. The question, the solution to that, your answer is deleted. I don't know why. Sure. Sorry. So no, you know how to rearrange those equations. Okay, cool. That's good. Again, you were saying Hooke's law, right? So if I say f equals minus k mx or x, let's take x, right? So now what we can do is if k, so the k will be the constant every time. So it is either f is given, we can find x, or if x is given, we need find f. So in both the cases, what will happen is what's going to happen is if x is there, so let's say minus kx is equals to f, and if um, so x will be So what will be, how I get the x? I have to divide by minus k this side and divide minus k this side, right? So I will get x equals minus f by k, right? No, no, you just because, but you have to remember that there is a sign, minus sign, right? Write it down, yes, to give the solution. So again, in mathematics or in the algebraic perspective, minus mean we have to subtract something, right? But in the real world, there is no such say thing like minus 5 meter. You will say minus 5 meter. Yeah. So that means if the answer is in minus, that means we are either, so if we are saying the extraction is like 5 centimeter, and if it is coming as minus 5 centimeter, that means it is squeezing the spring. Okay. And if it is calling like force, so force, if it is in the negative, it will depend upon the direction, upside or downside. That's it. Okay. Yeah. All righty. Now I was doing some work regarding. Let me see if I get something for the. Just give me a second, please. So as we are at the next topic, projectile, we are doing some sort of theory today, and then we will on next week. Okay, first tell me next week's program schedule, because from next week your school will be open, and let's wait till that the next week. Sorry. So we have just finished the motion. Now we are doing projectile motion. Then let's do something recovery. So this is the projectile motion. Maybe couple of classes, and then one class for force, Newton laws, circular motion, and momentum. Right. And then the free body diagram, hanging mass. So those are all related to that topic. We're doing some questions. Then work, energy, and power. And then the question is there Springs and Hooke's law, mm, torque and static equilibrium. Yes. So I think if we have 4 weeks and we have like four topics, we can pick one topic each week. So it eventually, so I have make a full, like, because it took some time to catch you up with the mathematics part, but at least we have finished along with both the topics related to the motion, that is projectile motion. And but I just want to deep dive into projectile motion because we have just touched up in just one, like, last 30 minutes of a class, right? So I have put like one full hour for that. And to cover up the other parts, it will be like, if we catch, let's say, 3 times a week, um, we will able to do at least two topics per week. So and have like one whole week to got a revision kind of thing, and literally you can do your other right. So what I am curious about is, for next 4 weeks plan, uh, I do have like 15. uh, let's bring this one. So we have this 6 week, 13 week, 20 week, 27 week whole, and then probably 1 week of the November, right? You said it will be on 16th, or not 16th, 17th week, November week, 17th or 14th. Exact actual exam. Okay. So we will have like 5 weeks then. So I will take like fifth week, this third week, as an as a buffer, right? And try to finish all the other topics in these 1, 2, 3, 4 weeks. Okay. And can we do like 3 days class? I do have, let's say, not Wednesday and Thursday, but eventually I do have Monday, Tuesday, and can we do on weekends? One class on week. Hmm? Okay. So let's do Monday, Tuesday evening, 6:30 to 8. And on Saturday, mm, what will be the best time for you? Oh, yeah, definitely. 2 to 3:30. Okay. Okay. Saturday 2:30. Oh, sorry, 2 3:30, and Monday 6:30 to 8, and this is for Jessica because and Jessica is also there for 6:30 to 8. Saharsh 6:30 to 8. Saharsh 6:30 to 8. Okay. And this is for Harleen Friday because I do have one more student, Harleen, in in the same class like you, year 12 physics. She's not feeling well, so she has taken off for the next week. But I have like fixed Friday evenings for her, just in case. So we have so for next 4 weeks, Monday, Tuesday, and Saturday. Monday, Tuesday, 6:30 to 8, and on Saturday 2 to 3:30. That's better. Okay, cool. All right, I need to go now. We have like around 1 hour 15 minutes. Uh, let Do you want me to do another class on tomorrow? Can we do? Okay, so tomorrow also at let's see, we can do it from 2 to 3:30. Okay. All right, and we will try to touch up some. So after this pivot equilibrium, we have nothing. I think so. Yeah. So there are 4 or 5 topics we will try to cover up because most of them are like interrelated. Spin beams, yes. Yeah, yeah. Electricity, I will do in one class only. Right. So everything is will be covered in one class. So it's not that big because most of the time I think I have touch up with the electricity part, but it's like one class will be sufficient for the electricity part. Right, so it's not that big, but again, to cover up the whole, at least we can go with like with the topic with 5 such questions each, and then we will look out for the questions which has been asked in the question paper. So that will be the pattern for our whole course, right? Yeah. Okay, cool. So I'm not going. Sorry. Oh, yeah, yeah, sure, sure, sure. Well, we will do it. And I'm also finding some questions which is related to. So I'm digging up some internet and find this whole library. And this book is quite good, and it is explaining each topic in very very detail. I love to educate in that manner, but we haven't have time. Let's say if you have time, and I was there for you in year 13, and if you take physics, definitely we will look to in that depth, right? Let's do on that day. Okay, no worries. So I will take some of the pictures and do some calculations related to projectile, why it's there, why it's how it's working. And even though we have done the notes, all of them I have already covered the projectile thing. Probably not here. I think it's there. Not here. Not yet. Yes. So we have done the linear motion, free fall, and projectile. So the motion is like a three-part thing. If we have touched all the things, which as I have, we will do it tomorrow. I have touched up those things, but still I need to do. We done some kind of theory and the questions related to that, and we'll dig a bit there so that it will give you a better understanding of the topic. All right. So we will see to that. Okay. Well, I will see you tomorrow. And Friday. Enjoy your Friday evening. All right. I will send you the notes. Let me first send you. Otherwise, I forget. Okay. This is today's save. Jessica, save. Tomorrow same time, 2 to 3:30. Today I was a bit late because I was coming from some other place. Let me send you the mail. Compose this and the notes. Today's notes. Open and send it. Okay then. See you tomorrow 2 o'clock. Have a nice evening. Bye bye.